Hello everyone. Let's talk about how can we write good unit tests. So this is not a discussion on what is unit test or how to use a particular unit testing framework. Instead, we are going to learn the best practices to write unit tests. So just to recap, unit test verifies that a known and fixed input produces a known and fixed output. So this is the method by which individual units of a source code are tested to determine if they are fit for use. So unit tests are typically written and run by developers to ensure that the code meets its design and behaves as intended. There is a myth that it requires time and I am always overscheduled. My code is rock solid, I don't need unit tests. So these assumptions lead to a vicious cycle like this. You write less tests, your code becomes less stable, you become less productive and accurate, and you feel more pressure, and that makes you write less tests again. But the truth is, unit testing increases the speed of development. Programmers think that integration tests will catch all errors and do not execute the unit test. But what happens is very simple errors, which could have been easily fixed and found in unit tests, take a very long time to be traced and fixed. Well, how to write unit tests and how to use different unit testing tools are beyond the scope of today's discussion. So the learning objective of today's discussion is writing good unit tests. That means by the end of the class, we should be able to answer the question, how to write good unit tests. So let's jump into some of the best practices to write unit. Follow the AAA rule. AAA stands for arrange, act, and assert. So it's a general pattern for writing individual tests to make them more readable and useful. So first you arrange. In this step, you set things up to be tested. You set variables, fields, and properties to enable the test to be run, as well as define the expected result. Then you act. So that is, you call the method that you are testing. And finally, you assert. That means you call the testing framework to verify that the result of your act is what was expected. So if you follow the AAA principle, and your test will be very clear and easy to read. Consistency. So test should be consistent. It should not be the case that test sometimes passes and sometimes fails. And this is called flakiness. So this is really dangerous. You should be very careful about flakiness and work really hard to avoid flakiness. So what can be flaky? Anything that is time dependent. Test may be failed at new year boundary or time-saving boundary. So if your test works with something that requires network, it may fail upon the network unavailability. Also watch out any random functions on your code. And another source of flakiness is multithreading. Anything involved in multithreading can be problematic. Atomic. So your test should only result pass or fail. There are no chances of partially successful tests. So tests should never depend on each other. If your tests have to be run in a specific order, then you need to change your test. For example, test B should not depend on the results of test A. Instead, you should make proper use of the setup and teardown features of your unit testing framework to ensure each test is ready to run individually. Unit test frameworks don't guarantee that tests are going to be run in any particular order. So if your test depends on the test running on any specific order, then you may find hard to track down bugs in your tests themselves. Single responsibility. Unit tests should be independent and should be responsible for one scenario only. You are testing the behavior. You are not testing the methods. That means if you have multiple behaviors in one method, you write multiple tests. If you have single behavior that consists of multiple methods, you write one test. For example, instead of writing 3 behaviors in one test, write 3 different test cases for the 3 behavior. That means it is suggested to write one assert per test, and each test can end up being very specific. So this way you will definitely identify for which behavior your test is failing. And then self-descriptive. As you are doing one assert per test, each test can end up being very specific. Thus, don't be hesitant to use a long, complete test name. A long complete name lets you know immediately which test failed and exactly what was the test was trying to do. And long, clearly named tests also can document your tests. So try to name your test to represent a past conditions. So let's see a few examples. Public void can make reservation. How about this? Is it a good test? Yes. So public void total bill equals sum of menu item prices. Yes, this is another good name. But how about this one? Public void test method tree. No, not at all. This is not a good test name. No conditional logic or loops. All inputs should be known. A method's behavior should be predictable. Expected output should be strictly defined. So there is no chance of if-else conditions. Instead, is split into two tests, then using if or case. So if test logic has to be repeated, it probably means that the test is too complicated. So call method multiple times rather than looping inside of method. Here is an example. Instead of using conditions inside a test case, you split them up as single test cases. Avoid the use of Assert.Is true. So avoid checking for a Boolean condition. For instance, instead of checking if two things are equal with Assert.Is true, use Assert equal. Because if your test fails, Assert true may give you something like some test failed, expected true, but the actual result was false. That doesn't tell you anything. Instead, use Assert equal. So it gives you some test failed, expected 7, and the actual result was 3. So which is more valuable as an error message. So some general guidelines, let's see here. The first test you write should be the simplest one. So the happy path. They should be the ones that easily and quickly illustrate the functionality you are trying to write. Then once those tests pass, you should start writing the more complicated tests that test the edge and boundaries of your code. And keep unit tests small and fast. Ideally, the entire test suite should be executed before code check-in. Keeping the test fast reduces the development turnaround time as well. So unit tests should test both sides of a given boundary. For example, if you are building some test for date and time utilities, try testing 1 second before midnight and 1 second after. Cover every code path if possible. This one is challenging as well, but if your code is designed for testing and you make use of a code coverage tool, you can ensure that every line of your code is covered by unit test at least once. And you should write some negative tests as well. That means provide bad input, because negative tests intentionally misuse the code and verify robustness and appropriate error handling. Write tests that reveal a bug, then fix it. So this is a powerful and useful technique. If you find a bug, write a test that reveals it. Then you can quickly fix the bug by debugging the test. Then you have an excellent regression test to make sure that if that bug comes back for any reason, you will know right away. And it's easy to fix a bug when you have a simple, straightforward test to run in the debugger. Each developer should be responsible for making sure a new test runs successfully upon check-in, and all the existing tests run successfully upon code check-in. So if a test fails as part of a regular test execution, the entire team should drop what they are currently doing and make sure the problems get fixed. If your code raises exceptions, then write tests to ensure that every exception you raise gets raised when it is supposed to. Run your test while you are writing code. Your test should run fast, enabling you to run them after even minor changes. If you can't run your test as part of your normal development process, then something is going wrong. Unit tests are supposed to run almost instantly. And if they are not, it's probably because you are not running them in isolation. Alright, this is it. So thank you for watching. I hope you will write better unit tests now. So stay tuned for the next one. Bye.